Today, drainage basins in many parts of the world are ungauged or poorly gauged. Notably, globally hydrometric networks are at risk due to possible declines in network coverage, associated observation record loss, and increasingly restricted access in terms of data availability. Within some river basins, headwater gauges have been lost in upland areas to focus on downstream sites close to population centres. Yet headwaters contain the majority of river and stream length, and they are especially vulnerable to change, but incredibly important for water resources and lowlands. Innovative field-based technologies, such as our lidar-based non-contact measurements of river water levels, can improve monitoring resolution and accuracy while providing cost-effective solutions.
The Indian Institute of Technology, Roorkee, located at the foothills of the Himalayas, has had a long-standing relationship with the Central Water Commission, NMHS India. In the early stages of interaction with CWC, especially with the Hydrological Observation Circle, managing the Himalayan reaches of the Ganga River, some key challenges came to the fore. The technology had to be sufficiently low cost compared to the technologies that are already in use for hydrometry within CWC. We were also presented with two technological challenges. First, the technology had to allow bank installation for monitoring of water level. Second, as one moves higher up in the Himalayas along the river Ganga, suitable installation on the bank will also have to account for deep valleys. So meeting these technologies challenges at low cost was what we set out to be when we proposed to Central Water Commission the development and installation of the lidar-based water level sensors.
Within this WMO project, we have trialed a new technology to measure water level in rivers based on LiDAR. And of course already many methods exist for measuring water level, but LiDAR has a couple of specific advantages. First of all, it is relatively affordable, robust and power efficient, but it's also a non-contact method which is particularly convenient in high energy rivers such as those of mountain environments where installing anything in the river is prone to damage. But another specific advantage of LiDAR is that it can measure water level at an angle, and that is different from other methods such as radar and ultrasound, where you have to install the sensor above the water level. And that is in many cases difficult to do, especially in places where you don't have any existing structures, or for instance where you have a riverbank which isn't stable. And so the advantage of a LiDAR is that you can install it further away from the river, measure at an angle and still detect the variation in water level. And so we've used an existing LiDAR sensor and adjusted it for this particular purpose and built around a automatic logger. And that's the one you can see here. So it's a very compact system. You've got the LiDAR here, which actually measures to the downside or at an angle. And then the logger itself, which is a logger made of off-the-shelf components, including a solar panel for power supply and the telemetry module so that you can send the data in real time. It's all based on off-the-shelf technology, open standards, open source, which makes it very convenient to adopt, adjust and integrate in existing operational systems such as those of the Central Water Commission.
Our goal collectively has been to involve the CWC engineers best as possible at all stages of the project and at multiple organization levels. This involved creating content to introduce open source ecosystems to engineers previously used to only off-the-shelf products.
Having the World Meteorological Organization's name attached to the project really helped with that, I believe. And the training module that we organized was really well received. Furthermore, the development of a dedicated graphical user interface, which actually had significant input from the CWC, has also been a very useful tool in building confidence in the new technique within the Central Water Commission. I really think that this graphical user interface has really built confidence in the innovative new LiDAR-based solution, and hopefully will ensure that the technology is fully embedded within the CWC beyond the end date of this project.